Yeah, I wasn't speaking. Now I am. Okay, so I'm looking at the requirements. This is for the inheritance part. This is the sample test. And I think there's only one more thing that I haven't covered so far, and that is final, the final keyword. So far, you guys know about final as when it comes to names, right? Like, for example, final string. So in this case, it means that this is only initialized once, this variable. After that, it cannot be changed. It becomes read-only. So you might be surprised to know that final is also used in classes. So you can do like final class student or final class person. You can also do it in a method in a class. So you have a class and in there you have a method. For example, toString. Ignore the caps lock thing. Word does that. Right. So you might know that methods can be overridden. So I'll show you an example of overriding a method in this class we created. And my IntelliJ IDEA is not opening for some reason. Okay, so we have this animal class, right? And to give you an example of overriding methods, I'll create a method in the original animal class because think about it, every animal makes some kind of noise. So we'll have public void make noise, and we can just print out animal noises because we don't know what animal it is, so it will just make some kind of animal noise. But we want the animals where we do know what the animal is. By the way, the cat also needs a constructor. So we create a constructor with animal type. So you can see age, name, animal type, and it just calls the super constructor, which will return an animal. So animals make a noise, but the animals that we know what type they are, we want them to make a specific kind of noise. Like dogs will make a bark and cats will make meows. So we can write the override annotation. And by the way, it's not necessary, but well, it's not guaranteed, it's not required, but I still think you should use the override annotation. It helps the reader read that you're overriding a method. And then you override the method, which was public void make noise. And alternatively, to make sure you don't make any errors, you can press Alt Insert and you can go override methods. And it will show you which methods to override from the parent class. By the way, object is because it's like, how all human beings and all monkeys go back to the same, I guess, class. I think it was called like Homo something. But all objects in Java are inherited from the Java lang object class. That's why you have these methods. Hash code equals to string. These are given to it by the original Java object, the ancestors. But we're not interested in that right now. So animal, the parent class, which method do we want to override? Make noise. So it automatically does it. And it also calls super.make noise. Super refers to the parent class. So super.make noise just means you use the original make noise. And let's just see what that does. I'll put the same in cat. And I'll go and I'll create a cat. Cat's age will be, I guess, 3. Pretty old for a cat. Name will be Whiskers. And animal type, I think animal type is given automatically. Okay. So we go to the main class. and we create a cat. We create a dog. It's 12. That's a normal dog age. So notice what I'll do anim1 dot make noise and anim2 dot make noise. Note how it only says animal noises. That's because the storage, like they're both stored in animal, but you might be thinking that's the reason they're making animal noises. But no, it's because if you see, their make noise function is literally just calling the super make noise function. So super is animal, so it goes to the animals make noise, and you can see it just says animal noises. Same with cat. So what if you want to override this behavior? You erase the super call and you just say print out when do we need to override? When the test asks for it. You can see here. So you create a person class, which is the parent class. It will have a toString method, right, to return a well-detailed string representation. However, on the student class, it says override the inherited toString method to return a well-detailed representation. So we'll have to override the inherited toString. But yeah, in this case, the base class, it provides some behavior, its default behavior, and you should ideally override it. So dog will make the woof woof bark bark, cat will, and now if we run it again, there's meow meow and woof woof bark bark. Now you might notice one thing, both of them are of animal type. So why are they doing different things? And for those of you that attended the lecture yesterday, this is polymorphism. So we see that both of them are in an animal container, but their actual object is a cat and a dog, and that's what Java sees. It sees if it's a cat, they will use the behavior that is here, and if it's a dog, they will use the behavior that is in the dog class. So that's what overriding does. And now, in the requirements, now we can start checking out other requirements because that's all you need to know about overriding. Okay, you can derive. You can. Okay, what is final? So final and override goes hand in hand. So I'll now tell you what final is. So as you know, final can be used in three places. Final can be used uh, in a field, like it can be used in a class name, like private final class animal or public final class animal. You can just do that. Or in a method, public final void. No, no. So what does each of those do? You already know what happens if you put final in a field. It stops it from being overwritten. What about in a class? If you put final after a class, it will stop that class from being extended. So we'll put here right now, public final. We'll see that instantly it starts causing problems. See, related problems, unclassified dog, cat. If you go here, cannot inherit from final aviation.animal. Forget aviation. Aviation is just the name of the package. But you can see that the second I make this class final, it cannot be extended. Cat also has a problem. So that's what final in a class name does. What if I put final in a method name, for example, make noise, because this method is being overridden. So if you put final in a method, it will stop that method from being overridden. So public final, you can see both of their make noise is more make noise methods start having issues. It says cannot override make noise in aviation animal. Overridden method is final. So that's all you need to know about final. Just these three applications, and this might also come in the exam. So just remember it. I'll remove the final now. Okay, what are the requirements do we have? Must be able to derive a class. You can now derive a class easily. Just extends mean derive. Must be able to use the final keyword on methods and classes. You know that. You must be able to implement the comparator interface. You know that. The last thing from B1 that we need to do is you must be able to define multiple top level classes. So what does it mean by top level? Now, up till now, you have only been declaring one class per Java file. So here is a file animal.java, and it only has one class. If you collapse this class, hmm, why isn't it letting me collapse? Okay, it's not letting me collapse this class because this is the only thing in the file. But this is a top level class. As you know, there's scopes in programming, right? For example, this integer age is in the whole class scope. But this variable, for example, no, this one, this age is only in this method. So top level means at the level of this file. I'll give you an example. If you can look at this class and airport.java, it has two top level classes in it. So you're in the file and you see public class airport implements comparable airport. So that's one class, but you scroll down and you notice there's another class in the same file. And if you've tried Java before, you know Java has a rule. You probably thought that it was only possible to put one class per file. But the requirement is actually one top level. So you can only have one top level public class. The other ones can be private and they can be private, then it's fine. So in this case, we have the public class airport, which can be accessible from other classes. And then we have the airport comparator helper class, which is okay. So in Java, if you don't put the public word, by default, I think it will be private. For classes, it will be private. For fields, it will be package private, I think. But yeah, if you don't put it, it will be private. So that's why it's allowed. So that's what it means to have top level classes. And if it's confusing right now, don't worry when we solve this problem. Next up, let me see how much time I have for this meeting. Meeting controls. Can someone tell me how long the meeting's been going for? I can't see the controls. Oh, still can't see the timestamp. Oh, well, I'll start solving it anyway. Let's see how far I can go before I have to start a new meeting. So let's look at the question we have for topic B1. It starts with define a class person. So, the parent class will be person. They will have the ID. They will have three fields. So I'll just put this on the side, put IntelliJ on one side, and I'll create a new project for this. I'll do it JDK22. So just a second to install the JDK real quick. New window. In the meantime, I'm gonna go refill my water bottle real quick. It's gonna install the JDK that we'll be using in the test. All right, hello, I'm back. And now we have a project with JDK22 up and running. Now I will start solving the problem. Now what the hell, it's still saying indexing JDK Corretto 22. Okay. I'll just set up the project files in the meantime. So we can see it says defining a class person. So we also have to see the package. What package do they want? Place it in the package people. The first thing you should look at is the package name because it's the first thing you create. So we can go. By the way, Zoom shows that there is a lot of noise coming from my mic. Am I clear? Like, is my speech clear? Because Zoom is reporting there's a lot of noise coming from your mic. You're Anand? Okay. Right, so the first thing we see is package. So we'll create a new package. New package, people. And inside the people, the first class will be person. So we create a new Java class, person. By the way, ignore that. This is just on my PC. Okay, what else do they want? Hmm. Okay, we'll start with person. So it has three fields. The class person, it has ID, string, name, string, age, integer. By the way, non-negative is just a guarantee from the professor that it will be non-negative. You don't have to worry about it. It will be an integer. So name the class as person and place it in the package. Done. Define a constructor that has the parameters. Okay, by the way, I recommend reading through the whole thing before starting developing because we also have to see the access modifiers of these fields. Will it be private? Will it be final? Will what, that kind of stuff. Use the default visibility for the fields. So default means you don't put anything. You just go. Uh, if it says you make the fields private, then you write private string. But it says default, so just go string ID. Then we have string name. Then we have int age, and these are the fields. Now we define a constructor that has the parameters for all the fields. So I'm going to go fast with this because you've already done the feedback test number 1, but if you have a question, just let me know. That's the constructor with all the parameters. And we need a constructor that has parameters for all the fields except age. The default value for age should be 0. Constructor. That's done. Use the default visibility for the fields. Already done. Make the ID. See, yeah, okay, I should have taken my own advice and I should have read the whole thing. Make the ID field read only. It's supposed to be final. Okay, what else? Okay, that's the only thing I missed. So it will be final string ID. And it doesn't really change anything with respect to the constructors because they'll be the same. It does affect the getters and setters though. Getters and setters because of course you're not going to put setters for a final field. The getters and setters are done. Override the inherited toString method to return a well-detailed string representation of the state. So to find how you need to represent the string, represent it in string, to go and find it. They will tell you the representation they want, by the way. But let's assume right now, because this isn't the actual exam. So let's assume the string representation they want is like this. Person, they want the person ID separated by a semicolon, then the name separated by semicolon, then the age. Because this is a very common format that is in the HLPL2 exam. So we override the toString method. We come here, we do our toString, and we just create an empty toString method. Okay, return this.id, this.name, this.age. So this.age. So that's the toString done. In override the inherited equals and hashcode methods to ensure the two instances are equal if and only if their ID fields are the same. So we just come here, alt insert, we do equals and hashcode, and it says ID fields. So that means we select ID and we deselect everything else. Boom, boom, done. There you go. You should support a comparison by implementing the comparable interface. The natural order of the instances is the following: age descending, name ascending, and ID ascending. So we go up and we implement comparable. See, that's a mistake people make a lot. And by people, I mean me. Implements comparable. It's comparable with other persons. So it gives an error. Okay, we implement the methods, we choose the compare to method, and boom, now we have the compare to method. Now it helps me to write the logic first. So what is this? First is age ascending. Second is name ascending. Oh, age is descending. My bad. age is descending, name is ascending, and ID is ascending. Now you can start. So the first thing you do is you check if the person O and our person has the same age. So you do if this dot age is equal to O dot age, well, not equal to. Oh, sorry, I didn't see the chat. I think yeah, it's sharing the same. Yeah, I saw the chat. It's sharing the wrong screen. Let me just adjust it. Now you can see it. Okay, I'll start over. I have just written the person class so far, and you can also see the requirements. So the first thing we do is person. We create the fields, final string ID, string name, int age. So if you don't put any like private or public, it will be the default package package visibility for all the fields. We also put it in the package people, which we create here. You already know how to create packages because you did feedback test one. And then we create a constructor. Then we have another constructor that puts the age equal to 0. Then we create the getters and the setters. Then we create the toString because now we are assuming that they want our object in this representation, which is very common in the exam. Then equals and hash code. You already know how to generate equals and hash code, but if you have a problem, do let me know in the chat. And now I'm implementing compare2 right now. So because this class requires here, it requires us to implement compare2. So comparable. So we have comparable, and once we implement the comparable interface, we have to implement the compare2 method. So for this, it helps to write the criteria down first in comments. It's a pro tip, and that way you don't have to keep looking back at the other screen. So age descending. First thing we do is check if our person's age is not equal to the other person's age. If it's not, then we can return integer.compare. And then, okay, after that, okay, it's supposed to be descending, so we put a minus in front. That's it. If anybody has a question about why I'm putting a minus here, let me know. But just a hint is it's because any comparison method returns either 1 or 0 or -1, depending on whether the current one is bigger than the other one, or they're equal, or the other one is bigger than the current one. And if you want to reverse this, you just multiply it with -1. If you multiply all of these with -1, it gives you -1, 0, 1, which is the opposite. Anyway, now we check if the name, okay, after this, it says name ascending. So we check if the names are equal. This dot name dot equals no dot name. If they're equal, we return. And after that, we don't check for equality in a ID because even if ID is ascending, it's the default, it's the final one. So we just do return because if age and name are equal to each other, then we just return the comparison based on ID. ID is it's a string, isn't it? Yep, ID is a string. So we do this dot ID dot compare to O dot ID. And that's it. That's the compare to method done. Comparable, this part is done. Can we use objects dot compare dot reverse? I think you can. Let me just check it. You can? Okay, great. I think it's just I'm kind of a boomer when it comes to programming, so I've been using this for a long time, so I just use this. And yeah, it's the person is right. It is the same thing. Behind the scenes, the same thing is happening. Yep. It's like a different algorithm behind the scenes, but it doesn't matter to you and it doesn't matter for the exam unless you're doing like super low level optimizations. But yeah, that concludes the person class. And now we create the student class. This is where inheritance comes into play. Student class is in the package people. So we go to people, we create new class, student. And what does the student class do? It says derive a class from class person. The name will be student and it is derived from person. Derive, the second you see derive, you're like, okay, it inherits. Inherits means the word extends. Let me see. Okay, now it doesn't give you a hint. You'll have to remember this. Extends. Student extends person. Now you read through the requirements. Define a constructor that has the parameters for all the fields. Define a constructor that has the parameters for all the fields except the age. The default value for that field should be 18. Define the constructor that has the parameter for all the fields except the age and program. The default value should be 18 and CSPSC. Package, private visibility for all the fields. Make Neptune read only. Getters in 82 string. Okay, so we'll start with the fields. It says make all the fields private and make Neptune read only. So private, final, string, Neptune. The other one is private, string, program. Okay, next up we have the constructors. Point number 234. The first constructor has all the parameters. So remember, this is where we use super. So we do constructor, all the fields. Actually, no, this is not fields. This is which superclass constructor we are referring to. So as you know, in the superclass, there is one constructor that takes all the fields of person. We'll do that. And which fields of people do you want? All of them. So I'll go through this real quick. Line is too fat. Yeah. Okay. So this constructor takes a string ID, takes string age, name, which are all from person. As you can see, it's the person fields, ID, name, age, and then string Neptune and program. So first it calls super ID, age, name. So what this does is it creates a person and it assigns the ID, age, and name. But that person is still of type student. So it returns that type here to get further initialization. Then you initialize the Neptune and the program. So next up is a constructor that has parameters for all the fields except the age. The default value will be 18. So now we create another parameter. Alt insert constructor. Which constructor are we targeting? So again, the same one. And this constructor will actually have to edit stuff. I think it's better if I write it by hand. So this constructor is public student. What does it take? It takes all the fields except age and program. So string ID doesn't take age. So string name, string Neptune, and it also doesn't take program. So first we call super and we pass in the ID instead of the age, as you can see here. We're still targeting the age one, string ID, age, and name. So since it's expecting age, we'll give it the default value of 18. No, yeah, we'll target that one. Age 18, and the name will be the given name. We're already given the name. Okay, and then we assign the stuff specific to this class, which is, wait, by the way, I got the warning from Zoom.